Hey kiddos, here's a spiral review for Spiral 16. I'm going to start off with the rational root theorem. This is going to be the last time that we see this topic. For the first part of this, we got to identify all possible rational roots. I gave you some nice, easy numbers to work with, like 120, which totally doesn't have a billion roots, or maybe it does. That's going to be plus or minus 1. And with that, that would be plus or minus 120. Plus or minus 2 would also work. And plus or minus 60. Plus or minus 3. And plus or minus 40. Plus or minus 4. And plus or minus 30. 5 works. Oh, this is fun. Plus or minus 5. And plus or minus 24. 6 works. Plus or minus 6. Plus or minus 20. I'd like you to notice that things are kind of merging together. Slowly, but they're getting there. 8's going to work. 7 does not. Plus or minus 8 and plus or minus 15. 9 does not work. 10 works, and that gives us plus or minus 10 and plus or minus 12. And 11 does not work. That gives us a total of 16 different numbers, and if we include the positives and negatives, we're at 32 different choices. Wow, this seems super pleasant. But let's just start dividing. I want to do this in a really organized way, so I'm going to start with 1s or 2s, maybe just 1s. So if that's going to be x minus 1 to give me a positive 1, we're going to have 1, 5, negative 26, and negative 120. All right, bring the 1 down, multiply, we get 1, add, we get 6, multiply, we get 6, that gives us negative 20, and negative 20, which gives us negative 140. Not anywhere close. Okay, so 1 didn't work. I also noticed that none of these numbers, like this, just kept getting worse. And I might switch to 2 to see if I can make those differences get any smaller. So 2 would be x minus 2. Same thing, 1, 5, negative 26, negative 120. We get 1, we're going to have 2. That's a 2, okay. Then 7. 14, and that's going to be negative 12. 2 times negative 12 is negative 24, and that does not get me anywhere close. That's even worse, negative 144. I'm going to kind of keep going up and maybe see if I can make some grounds here. This is, I've gotten 2 that didn't work already. I don't know, maybe I'll even jump to like 6 or something. I realized that I said I was going to do some kind of an organized method, and I'm definitely not doing that right now because I'm in the mode of I don't really know what to do, so I'm going to keep trying things. So 1, 5, negative 26, negative 120. 1, 6, 11, 66. Oh, this is looking more promising. I'm getting weird things going on here. And that's going to be 40, and 6 times 40 is 240, and that still gives me something that doesn't work, but now my numbers are really big. Maybe I'll try to go somewhere between those things, like with 3, and we got x minus 3, and 1, 5, negative 26, negative 120. 1, we get 3, 8, we get 24, negative 2, and that's going to give us negative 6, which does not give us 0. Oh, this is going so well. I guess maybe that's those are closer numbers to what we're looking for. Maybe try 4. And let's put the L on the wrong side. So we got 1, 5, negative 26, and negative 120. That gives me 1, 4, 9, 36, That's going to give me 10 and 40, and none of these are working. I guess the only number I haven't tried in this range is going to be 5, and if this doesn't work, we have to have a new system of attack, maybe go after those negatives that I've been avoiding. So that's x minus 5 would give us 5, 1, 5, negative 20, and negative 26, and negative 120. That's going to be 1, 5, 10, 50, 24, 120, and 0. Wow, on the 6th try we got that. So that means 1x squared plus 10x plus 24. A times c is going to be 24 with a b of 10. That's going to be 6 and 4. So my first one from that equation was x minus 5. That's going to give us x plus 6 and x plus 4. So we're going to have zeros of 5, negative 6, and negative 4. And looking at those two numbers, I understand now why we didn't get an answer. We were only trying the positive ones, and the two that we did not get to by trial and error were both negative values. Okay, next up we've got to talk about this graph. And then looking here, as x goes to negative infinity, that's going to the left. So what's happening over here? Y is going to negative infinity 2 because that's going down to the left. As x goes to infinity, that's going this way. So we're going right and up. Y goes to positive infinity. For the next part, as x goes to negative 6 from the right side, I'm going to write from the right. So we're talking about this part. Y is going up, therefore it's going to infinity. And as x goes to negative 6 from the left side, so now we're talking about this part of the curve, we're going down, that would be negative infinity. Okay, for the next one, we've got to find some important characteristics of the graph. We're going to talk about this in two different ways. The first is to look at this vertical asymptote. That comes from whatever makes the bottom 0, so that would be at x equals negative 2. When equations look like this, the last number is the horizontal asymptote, so that would be y equals negative 6. The x-intercept, that's the hard one for us to find. The y-intercept is where x equals 0. I'm going to come back to the x-intercept in a minute. So that would be 1 over 0 plus 2 is 2 minus 6, which is negative 5.5. So y equals negative 5.5. And for the x-intercept, we're going to have to do some math, because that's where y is equal to 0. We get 0 is equal to 1 over x plus 2 minus 6. I'm going to add 6 to both sides. 6 is equal to 1 over x plus 2. And I've got to multiply both sides by x plus 2. I'm going to bring this work down here so it's out of the way. So that would be x plus 2 times 6 is equal to 1 over x plus 2 times x plus 2. My x plus 2's on the right cancel. And on the left, we get 6x plus 12 is equal to 1. Minus 12 divided by 6, we get x is equal to negative 11 over 6. Negative 11 over 6. The y-intercept we said was going to be, I like how I'm looking at the x-intercept but can't see that, negative 5.5. The vertical asymptote is going to be negative 2. Horizontal asymptote is going to be negative 6. I'm going to scroll up a little bit to see that. And something went wrong in the way that I graphed this. And if I look at this thing that went wrong is I put this in the wrong place. Negative 11 over 6 is not less than negative 2. So I'm going to put that point here, negative 11 over 6. and then graph my curve. It's going to go through those 2 points, a nice smooth curve on this side, and then the opposite corner. Okay, we talked about a second way to kind of set this up. I'm going to do this off to the side, and the only thing I'm going to do is to think about this as two things being added together. And to do that, I need some common denominators. So I'm going to write this as 1 over x plus 2 minus 6 over 1. And to get common denominators, which are going to be x plus 2, I'm going to do this as negative 6, x plus 2, and in the bottom, x plus 2 as well. This is just finding common denominators for this. That would give us on the bottom x plus 2, and on the top we'd have 1 plus negative 6x minus 12, which is going to turn into negative 6x minus 11 over 2. Over x plus 2. And that's a rational function we're better at graphing than the ones that look like this. Next up, we've got simplifying rational expressions. These are going to be based mostly or entirely on multiplying, dividing, or none of those altogether. One of the ones I'm going to do is going to be based on factoring. The other one will be factored for you. Okay, so looking at the first one, the top is going to be regular a times c factoring. Things that multiply to 5 and add up to negative 6, that's going to be negative 5 and negative 1. So that's going to factor into x minus 5 and x minus 1. On the bottom, I've got a little bit more work to do. I can't do anything yet. I noticed that both of these have an x in them. That means I can take an x out, and that would leave me with x squared and minus 25. And furthermore, x squared minus 25 is difference of two squares. So on top, if we got x minus 5, x minus 1. On the bottom, we've got x, and then x minus 5 and x plus 5. Okay, at this point we are fully factored. Excluded values are going to be based on the bottom. X can't equal 0. X minus 5 can't equal 0, therefore x cannot equal 5. And x plus 5 cannot equal 0, therefore x cannot equal negative 5. Those are my three excluded values. And then finally, we got to simplify this. The only thing they have in common is an x minus 5. That will leave me with a final answer of x minus 1 on top and x times x plus 5 on the bottom. The other video ones are already factored for us, so this is going to be a matter of kind of identifying excluded values and then doing some math to simplify this. We got a whole bunch of excluded values because we got only 4 different things. Those are really the same on the bottom. So my x vals, x plus 2 cannot be 0, therefore x cannot be negative 2. X minus 4 cannot be 0, therefore x cannot be 4. X cannot be 0. And finally, x minus 5 cannot be 0. Therefore, x cannot be 5. Now that I've done my excluded values, we've got to take care of this division. A lot of you are using keep, change, flip as a methodology. That's fine. We're multiplying by the reciprocal. And when you do that, you get x times x plus 3 times x minus 5 over x plus 2 and x minus 4. On the other side, we've got a 3 in the bottom. I told you you're not going to have variables in the bottom that you have to check twice. Times x plus 2 times x minus 5. And here we have an interesting thing happening. Only the x plus 2's are the same on the top and the bottom. And that leaves you with a weird equation. That's, well, x times x I could write as x squared. We've got an x plus 3. X minus 5 and x minus 5 I could write as x minus 5 squared, although you could leave those separate. And then on the bottom, we're going to have a 3 times x minus 4. You could also write that as x minus 4 times 3. Doesn't really matter. And then finally, we've got to solve some equations. This is the new stuff for this cycle. The first one, we got to do some factoring. We're going to find some excluded values. Hey, this sounds really familiar. And then solve that equation out. At first, I've got difference of two squares. That's going to be 1 over x plus 3 and x minus 3 plus 2 over x minus 3. I'm going to leave a little bit of space because I know I'm going to have to find some common denominators. And 4 over x plus 3. Okay, excluded values. I know that for this, x cannot be negative 3, and x cannot be positive 3. So if I happen to get one of those answers that can't work for this problem, I'm trying not to make those, but if I do things on the fly, which this problem was made, that sometimes happens. Okay, I'm going to try to get the same denominator in all three of my fractions. So I'm going to look for x plus 3's. My second fraction does not have that. So we need an x plus 3 over an x plus 3. And now I'm going to look for x minus 3's. My second one has that, but my third does not. And by the way, my third does have an x plus 3. So we're going to have an x minus 3 there and an x minus 3 there. That's going to give us something that, if you'd like to think about this as 1 plus 2x plus 3 is equal to 4 times the quantity x minus 3. And all of those are over the same denominator. We talked a little bit in class about if you ever get the denominators to all be exactly the same, you can entirely eliminate them from the problem, which will leave you with 1 plus 2 times the quantity x plus 3 is equal to 4 times the quantity x minus 3. So that's 1 plus 2x plus 6, doing some distribution, is equal to 4x minus 12. I'm going to minus 2x to both sides to get a 2x there. 1 plus 6 is 7. I'm going to add 12 to get 19. We get x is equal to 19 over 2. Since 19 over 2 is not one of my excluded values, we are okay. I wasn't meaning accidentally giving you a problem that doesn't work out right. All right, for the next one that is marked as a video, this one's set up a little bit easier for us. I'm going to start with factoring, nothing to factor. Excluded values are going to be, based on the denominators, x cannot be negative 2, x cannot be negative 3. So I'm going to multiply both sides by both denominators to kind of get these things started. We're going to multiply by x plus 3. Ooh, that was a fun shape. I have no idea what caused that. I'm going to undo that. Zoom out, ooh, that also disconnected some things. That's interesting. Okay, well, I'm going to multiply this by x plus 3 as well, because apparently I can't move my page. On the right side, those cancel out. And on the left side, that's going to end up giving us something to distribute. I'm also going to multiply by x plus 2 on both sides, and using my terrible notation because things are not moving the way I want them to, we're going to have things kind of stacked. On the left side, those cancel out, and on the right side, that gives us something to distribute to. So on the left, we've got x squared plus 3x. On the right side, we're going to have 4x plus 8. And in order to try to solve this, I'm going to bring everything over to one side. So we've got x squared minus 1x and minus 8. I'm already going to see that this is not factorable, so you'd have to use the quadratic formula, which was not my intent. And again, this is what happens if I make problems up on the fly. I actually thought that I had nailed this one and gave you one that was totally factorable, but apparently I did not. So I'm sorry for that. We're not going to finish solving this. You'd have to solve for both values and check to see if they didn't work. And again, not my intent here. The one for your spiral I'm going to build a little bit differently so you don't have to worry about this showing up.